Right, radicals. Ooh, fancy stuff, not very difficult. Right now, these things are in exponential notation. You see how this is in the exponent?
Mm-hmm.
Radical means you're gonna have a root somewhere, okay? A root or something like that. This is called a rational exponent if you have something there, and this is a radical. This basically comes down to using the rules of the exponents, which is pretty easy. Well, I guess that's relative, but there's only 3 rules that you're gonna have to know. If you know, you know. Oh, there's more than 3, but it basically comes down to this. If you have AB times AC, the bases are the same, you add them up. If you're dividing, the bases are the same, then you subtract them like that, okay? And then finally, if you have an exponent outside an exponent, for example, 2 power 3 times 4, then you multiply the exponents. In this case, it's going to be 2 power 12. That's one thing. These are called the exponent laws. But you don't need any of this for this question. These questions are a little bit basic. All you have to understand is that if you have something like this, a to the power of b over k, or b over c, doesn't matter, the denominator is your root. It becomes the kth root of a power b. Okay, and you know if it's a negative exponent, you need to throw it in the, well, you need to swap positions. You need to throw it in the denominator or the numerator to make it positive, and only then can you evaluate. All right, let's look at these questions. Question A, 49 to the power of 1 over 2. The question says, first, write it in radical notation. That means you're gonna have to rewrite it something like this. There needs to be a root somewhere. What's gonna be the first step?
You change it into the square root of 49.
You can't right now. You can only do that if you have a positive exponent. So the first step would be to make the exponent positive. How do we make a negative exponent positive? You throw it, right? Just
Mm-hmm.
toss it. Right now it's in the numerator. There's an invisible denominator of 1. We're just going to throw it in the denominator. So it becomes 1 over 49 to the power of 1 over 2. The negative exponent has become positive. Now what do? You're going to throw this. You see this 2?
Mm-hmm.
This becomes your root. Whatever is in the denominator is always going to become your root. So this becomes the second root, or the square root of 49 to the power of 1. What's the square root of 49 to the power of 1?
7.
7. So the final answer is 1 over 7. This portion here is called the radical notation. Okay?
Mm-hmm.
This thing here is called the rational notation, or the exponential notation. Radical notation means you're going to have some form of some root somewhere. That's question 1. What about B? What do we do with this? Do we throw it in the denominator?
No.
No, we don't, because the exponent is not negative. It's the base that's negative. So what do we do with this? We're going to completely skip this step. We're going to move on to the second step.
You turn it into the cube root of
Yeah.
-8.
What's the cube root of -8?
-2.
Yeah. Same idea here. This is going to be what? For part C. It's going to be the 4th root of 10,000, okay? Like
Mm-hmm.
that. Now, what's the 4th root of 10,000? Plug it in, it's going to be 10. And that's the answer to this question. In other words, look at this, 10 power 4, okay? 10, that's not the answer to this question, this is just on the side. 10 power 4 is 10,000. The exponent that 10 has is the number of zeros the final term will have. So if it's 10 power 6, it's going to be 1 with 6 zeros. That's a million. Okay, like that. 10 power 9 is a billion, 10 power 12 is a trillion, and yada yada. So this bit here is called the radical notation. This thing here, the nth root, this is called an index. Okay? Square root, there's an indivisible 2 there, but here the index is 3. That's your nth root. It can be anything. This number depends on what the denominator here is. That's called the index. Not super important, but. All right, how do we do this one? 27 to the power of 2 over 3.
It turns into the cube root of 27 squared.
Yeah, cube root of 27 squared. Now here, you can do either way. You can either do 27 squared and the cube root of that, okay? Or you can do this. The order here is not super important. You can do the cube root of 27 first and then squared. This is the way to go, because this you can do it in your head. This one, I don't know what 27 squared is. Probably like what, 700 something, but whatever, that's not important. You're gonna do it this way, okay? The order here is not important. You can do either whatever way is easier for you. Both of them will give you the same answer. What's the cube root of 27?
3.
Yeah, so you can either do 3 squared or you can do the cube root of 729. 3 squared is a 9 and cube root of 729 is also a 9. But this one you're going to have to use a calculator. This way you don't. So this is a little bit better. So the order here is not important. You can either do the root first or you can square it first, whichever one is easier for you. These are called rational exponents. Again, I just want to emphasize this is the radical form, okay? Rational exponents versus radical form. You can go from one to the other pretty easily. Let's look at this. Negative 27 to the power of 4 over 3. What do we do here?
It turns into the fourth root of negative 27
No,
cube.
no, not the fourth root. The
Oh,
denominator
the
is your
third.
index. Yeah, it's going to be the third root. So it becomes the third root of negative 27. I like doing it this way because I can do this in my head. So what's the third root of negative 27?
It's negative 3.
Yeah, it's negative 3. So you have negative 3 to the power of 4, which is 9 times 9, 81. The way I was looking at it is this. Negative 3 to the power of 4 is negative 3 squared, negative 3 squared. Both of them are 9s, and then that will give you 81. 16 to the power of negative 0.75. What do we do here?
It's the same as negative 3 over 4.
Yeah, it is. Now what?
Since it's negative, you have to put it under 1.
Yeah. What's the next step?
Then it turns into the fourth root of
Yeah,
16 to the power of 3.
right. What's the fourth root of 16?
It's just 4.
No, it's not. Fourth root of 16 means some number to the power of 4 is 16. 4 power 4 is 256. If you have a calculator, yeah, the
Mm-hmm.
way you do this, sometimes it gets tricky. Like, what's the 10th root of 1024 or something like that? We want to find what the fourth root of 16 is. There's two ways to do this. Either you do 16 to the power of 1 divided by 4. That's one way. Or you do 4, and then there's a button on the calculator called the x root. which comes after you press second and the square root function, and then you type 16. Both of them should give you 2.
Mm-hmm.
Let me just double check. I don't have the calculator you have, so it's weird for me, but there's 2 ways to do this. So what's the 4th root of 16? It's 2, okay? It is
Okay.
not 4, it is 2. So we have 1 over 2 cubed, you have 1 over 8, and that's gonna be the final answer. What's the difference between a rational number and an irrational number? Pi, which is 3.141596. Is that a rational number or irrational number?
Irrational.
Right, so pi is here. What about 1.33333 recurring?
It's rational
So why is it rational?
because it's repeating.
So a rational number, okay, the definition is if you can rewrite it as a fraction, then that number is rational.
Mm-hmm.
1.3, that's just 1/3, 1 1/3, so that's 4 over 3. Rational numbers, even though it doesn't necessarily have to repeat, maybe I guess it does, because anything with a fraction will eventually repeat. If you can write it as a fraction, then it's a rational number. If you cannot write it as a fraction, then it's an irrational number. Now here is where you have to start using the exponent laws. What do we do here? What will be the first step? Look at the root 8, root 8. How can we write that as that's in radical form, the term root 8, square root of 8. How can we write that in rational form, which just means you need a exponent,
8 to the power of 1 over 2.
right? 8 to the power of 1 over 2, and then you're just going to use the rules. Step 1, 8 power 5 over 6 times 8 power 1 over 2, all over 8 power 5 over 3. Look at the numerator. You're going to use the exponent law of addition. If you have a power b times a power c, you need to add the exponents, okay? So it becomes these two numbers, they are your b's and your c's. You're going to add them up. So it becomes 8 power 5 over 6 plus 1 over 2, like that.
Mm-hmm.
What's 5 over 6 plus 1 over 2? So that's 4 over 3. So 8 power 4 over 3 over 8 power 5 over 3. Now you have a division, or you have a fraction, not a fraction, it is a fraction, but you have something over something, like that. Then you're going to use, this is called the quotient rule. You're going to subtract it. Product rule is this, the first one. You add it up. The bottom one is called the quotient rule. You're going to subtract. So here, you're just going to do 4 over 3 minus 5 over 3, like that. That is 8 to the power of negative 1 over 3, right?
Mm-hmm.
How can we evaluate 8 to the power of negative 1 over 3?
You put it under 1.
Yeah, you put it under a 1, so this becomes 8 to the power of 1 over 3, which is the cube root of 8, which we know is 1 over 2, and that's the final answer. So here you have to use the rational to radical. You need to know the conversion process. It's pretty simple. And then from there, you need to know these rules, the product rule and the quotient rule of exponents. Here we can speed run this, okay? It looks like a lot, but it honestly is not that a lot. All of these are like 10-second answers. Write in radical form, square root of 49, cube root of negative 125, fourth root of 81, like that, okay? Now it says evaluate without using a calculator. We know 49 square root is 7. That's easy. What's the cube root of negative 125?
It's -5.
Right. What's the fourth root of 81?
3.
Yep. On a calculator, you can do this. And that'll spit out 3. All these are one-step answers, honestly. It's nothing terrible. This one, it says write in exponent form and then evaluate. Alrighty, exponent form means something like this, okay? You're gonna throw the root, whatever the index is, right? Index means the root here. You're gonna throw those in the denominator. This was supposed to be 512. All right. This one, if you know, you know. If you don't, you just plug it in the calculator. The ninth root, I think, of 512 is 2, because the 10th root is 1024. Do you have a computer class?
Not exactly.
Can you take computer science? Do you know if in grade 11, 12?
I think 11 and 12 you can.
Okay, so if you I would recommend taking computer science. It's a very good. I don't know what you have to give up though to take that, but computer science is a good subject to learn. It's because this 512 is a power of 2, okay? Eventually what you get is you get 1024. 1024 kilobytes makes 1 megabyte, okay? A lot of the things, the code that computers run on are all powers of 2s. Bare bones, everything computer does is zeros and ones, binary. That's all it can read. Uh, and then it converts it into base 2s. It converts it into many different bases. It converts it into base 10s is what we see when we look at a computer screen, all the numbers and the letters. Base 16s, there's a bunch of different bases. But bare bones, computers, everything it knows, all its functions, it's just a combination of zeros and ones. It can only read zeros and ones. But then this powers of 2 also comes into place because this is the first conversion it does. Anyways, 512, 1/9 is 2. 27 to the power 2 over 3, we've already seen this. This is cube root of 27 squared, which is 9. What about e? E is a little bit more difficult. What do we do with e? What you can do is you can distribute the root inside, okay?
Hmm.
You can do -32 to the power of 1 over 5 like that. Then you can do 243 to the power of 1 over 5 like that. Plug this in a calculator. -32 to the power of 1 over 5 is -2. 243 to the power of 5, I think it's 3. And that's how you do that question. Cool?
Hmm.
You can distribute the exponent. So for example, if you have ABC over b squared c cubed to the power of 1 over 6, this 1 over 6 applies to every single element inside of that bracket. But these two, you have to use the exponent rule of rationality of exponents, where you have to multiply them. A power b to the power c is a power b times c. So what you do is you multiply this with this. So this becomes 2 over 6, 2 times 1 over 6, and then this becomes 3 over 6, like that. The point being, the exponent applies equally, distributes equally to every single element inside of that bracket. These are also pretty simple. It says express as a single power. So we don't need to evaluate it. We just need to write this as a single power. What do we do for D? Do we add them, subtract them, multiply them, divide them?
You multiply.
Yeah, you multiply them. What do you get? If you multiply those two exponents, what do you get?
To the power of -1.
Yep, and that's it. What about for E? What do we do there?
You subtract.
Yes, so you get 9 to the -1 over 5 minus 2 over 3. Common denominator, this is elementary stuff, but the common denominator here is 15, okay? You know how to do this, right? Multiply this by 5, multiply this by 5, multiply this by 3, multiply this by 3. So you get -3 over 15 minus 10 over 15. So you get 9 to the -13 over 15, and then you got to throw it in the denominator to make it positive. Usually you want to express your answers in positive exponents. What about F? What do we do there?
You add and then you subtract.
Yeah. So this becomes -4 over 5 plus 1 over 15. And if you're confident, you can even do it in the same step like that. So -4 divided by 5 plus 1 divided by 15 minus 2 divided by 3. It's -7 over 5. And then you throw this in the denominator because the question said express as one single exponent. And that'll be the answer to this question. Pretty straightforward. It says express as a single power, then evaluate. What do we do here? For the first one. What is √5 as an exponent?
5 to the power of 1 over 2.
Right, so you have 5 to the power of 1 over 2 from the first one. You have 5 to the power of 1 over 2 from the second one. You have the same base. You're multiplying. What do you do?
You add.
Yep. So you get 5 to the power of 2 over 2, which is 5 power 1, which is just 5. And that's the final answer. What about B? What can we do here?
It becomes -16 to the power of 1 over 3, and then 2 to the power of 1 over 3.
Yeah, that's right. So we have -16 to the power of 1 over 3, and then 2 to the power of 1 over 3. Now what?
You subtract.
Can you subtract? You can only subtract if they have the same basis. 16 and 2 are not the same numbers. You have a different base on top and a different base on the bottom. Right? Do you agree with that?
Mm-hmm.
You need to express -16 as a power of 2. Only then can you subtract. Think about it. How do you write 16 or -16 as 2 power something?
2 to the power of 4.
That'll be positive 16. What about negative? This is how you do it. Negative 2, okay? To the power of 4, like that. Notice this 4 doesn't apply to this negative sign. Okay? This 4 does not apply to that negative sign. And then you have 2 to the power of 1 over 3. On the top, open this bracket. So you do 4 times 1 over 3. So on the top, you get negative 2 to the power of 4 over 3. On the bottom, you get 2 to the power of 1 over 3, like that. This becomes negative 2 to the power of 4 over 3 minus 1 over 3. Negative 2 to the power of 3 over 3, which is 1. So the final answer is negative 2. This step here is crucial. Writing negative 16 as negative 16 is negative 2 power 4. This negative sign does not apply to the 4. Okay? And once you have that, just multiply the exponents, subtract, and you'll get the answer. Not too bad from there. C is looking super wacky. Let's look at C. What do we do for C?
You change them all to the power of 1 over 2.
Yeah. Does that help us? Could definitely do that, right? Here's some radical algebra. If the indexes are the same, you know what I mean by indexes? See here, the index is 4. The index here is an invisible 2, 3, 3. If the indexes are the same, you can kind of combine them. So here what I'm going to do is 28 times 4. I'm just going to multiply them as one big index, 112 over 7. Same idea here. The indexes are the same. We can combine this as 112 divided by 7, which becomes the square root of 16. What's the square root of 16?
4.
4. So just like when the bases are the same, you're allowed to add them, right? Or subtract them depending on what the question is. If the indexes are the same, you're allowed to combine them. You can treat them as like terms. But you can't do this though. You can only do indexes. This thing you can only do for multiplication division. You can't do root 28 plus root 4. This is not root 32, okay? This is a mistake. This is not true. But root 28 times root 4 is root 112. And if you do root 28 divided by root 4, that'll be root 7. Multiplication and division is good, but plus and minus, you can't do that. We'll see that in a little bit. You can only do this if the root and the indexes are the same. For example, 3 root 2 plus 7 root 2. Here, our roots are both root 2's. It's like adding 3a plus 7a. Basically, that's what it is. The roots are the same. The indexes are the same. This becomes 10 root 2. Only then you can add them. But here, you can definitely multiply and divide them, and that'll be the answer. Same idea with D. They have the same indexes, right? This bracket being here makes absolutely no difference. With or without that bracket, the question and the answer will be exactly the same. What we're going to first do is we're going to combine everything into one big root 4. Becomes 18 times 9 divided by 2. 2 goes into 18 9 times, so we have the 4th root of 81. What's the 4th root of 81?
3.
3, yeah. Right. And this is it. Let's look at a bunch of these guys. Are you okay so far? Is this what you've been doing in class?
Mm-hmm.
It's not too bad, right? Just follow the rules. Just remember the rules. Doesn't matter how complicated things look. Like eventually, I'm going to show you. I don't want to freak you out. But eventually we can do things like these. There's no numbers here, but irrelevant. We can completely do that. How difficult does it get? What's the end game here? What's the final game? Let's look at the most difficult question we can find. Something like this. You see this? Looks very tacky. Numbers and letters both are involved. Does not make 1 ounce of a difference. All the rules, if you know the rules, just go step by step and you'll get the answer. For example, if we're looking at these guys, this is a 2-step answer for the first one. What's 49 to the power of 1 over 2?
7.
What about 16 to the power of 1 over 2?
4.
4, right? That's it. So you see, the answer is 13, 1 and done. D is the same. It looks a little bit difficult, but how much more difficult could it possibly be? We know this one is 1 over 128 to the power of 5 divided by 7, yeah?
Mm-hmm.
Minus 16 to the power of 3 over 4. That means this guy is the 7th root of 128 to the power of 5. Same thing here. This guy is the 4th root of 16 power 3. What's the 7th root of 128?
2.
Yeah. So this becomes 1 over 2 power 5. What's the 4th root of 16?
It's also 2.
It's also 2. What's 2 power 5?
32.
32. Minus, it's 1 over 32 minus 8. You take the LCD, so that means you're going to have to multiply this by 32 on the top and 32 on the bottom. So 1 divided by 32 minus 8, and you'll get that the final answer is negative 255 divided by 32. And that's the end of the question, right?
Mm-hmm.
Was this difficult?
No.
Everything is just like that, okay? It may look terribly difficult, but you just do step by step. It's just some extra steps. And this is going to be harder than what you do in class. So if you can do these, it should be a breeze. Same idea here, right? We shouldn't even waste any time with this. This is the cube root of 27 squared, the 4th root of 81 cubed. That's 9, that's 27. The answer is negative 18. You don't even need anything here. What about E? What do we do with that first term there?
It turns into the cube root of 16 squared.
Does it? Think about it.
No, it turns into the square root of
Yeah,
16 cubed.
yeah. Square root of 16 is a 4, so it becomes 4 cubed. This becomes 1 over the square root of 16. This becomes an 8. This becomes the cube root of 27 squared, right?
Mm-hmm.
64 plus 1 over 4 plus 8 minus cube root of 27 is 3. 3 squared is 9. And then I don't want to deal with that fraction. Plus 8 minus 9, the final answer is 63.25. And you are done. This question is the same. We can kind of skip this. Let's just do these ones on the side. It says express as a single power and then evaluate. How much more difficult could it be? What do we do with E?
You multiply.
Yes, you multiply. So that becomes 16 to the power of 0.5 over 16 to the power of 3 over 4. That's the 16's 1 over 2. This is the 4th root of 16 cubed. That's a 4. This is an 8. And that's the answer. Or 1 over 2. What about F? What do we do here? They have the same bases, right? On the top and on the bottom. Everything is an 8. On the top, we're just going to multiply them. Oh, sorry, you can't multiply on the top. You need to add them because they're being multiplied. On the top, you add them. On the bottom, you multiply them like that, right?
Mm-hmm.
This becomes 8 to the power 0.5. That becomes 8 to the power negative 1.5.
And
What do
then
we
you
do?
subtract.
Yeah, you subtract. What's 0.5 minus negative 1.5?
2.
2. So the answer is 8 power 264. So there's a cube. You know what a cube looks like. All these three sides, length, width, and height, are the same for a cube, yeah?
Mm-hmm.
Cube is basically a square in 3 dimensions. What's the formula for the volume of a cube?
It's just the length cubed.
Yeah. So we know volume is L cubed. They've given us the volume and they're asking us to find the length. So it's going to be 0.015625. That's the volume equals L cubed. How do you solve this for L?
You cube root.
Yeah, you cube root. So it's going to be 0.015625 to the power of 1 divided by 3. It's 0.25. 0.25, what's the length? What's the unit of length?
It would just be meters.
It'll just be meters, yes. And that's the answer. There's a question for you. The answer to this and the answer to this, are they going to be exactly the same?
Yes.
Yes, because 4 over 3 was just 1.33. The answers there are going to be exactly the same. This one, communication problem. Explain why this is possible, negative 100 to the 0.2, and why negative 100 to the 0.5 is not possible. What's our approach here? It's a communication problem, so there's a lot of ways to answer this. There's no one right answer. Any ideas? Think about it this way. We're going to turn it into exponential forms. What's 0.2 as a fraction? What's 0.5 as a fraction? Maybe we can start here.
0.2 is 1 over 5.
Yeah, 0.2 is 1 over 5. So we have 100 to the power of 1 over 5, whereas here we have negative 100 to the power of 1 over 2, right?
Mm-hmm.
This means this is the fifth root of negative 100, whereas this means this is the square root of negative 100. Now think about square roots. Can you take the square root of a negative number?
You can't.
You can't. What this means is there exists some number, right? We don't know what that number is. There exists some numbers. If you square it, you get negative 100. But we know any number that you square will always be positive. Like negative 5 squared is positive 25. Doesn't matter which number you square, that will always spit out a positive number. You cannot take the square root of a negative number, okay? Whereas this one, by the way, you also can't take the fourth root, sixth root, eighth root. You can't take, the index cannot be negative, okay? Sorry, the index cannot be even. If it's a negative number inside the root, okay, the index cannot be an even number. Like the eighth root of negative 100 does not exist. Same thing with the 1002nd root of negative 100. Simply does not exist. But if the index is odd here, right?
Mm-hmm.
If the index is odd, then you're good. Odd can do both ways. It doesn't matter if it's a positive number, negative number. Odd indexes, there exists a solution. Whereas for an even index, if there's a negative number, there is no solution. That's why you cannot evaluate this guy here, because the index is even and there's a negative number inside. Whereas this one, the index is odd. Odd doesn't care. Odd swings both ways. Right? 125 to the negative 2 over 3 in radical form. Then evaluate, explain each of your steps. Alrighty. What's the first step here?
You throw it under 1.
Yeah, let's throw it. Let's toss this guy. What's the next step?
It turns into the cube root of 125 squared.
All right, cube root of 125 squared. What's the cube root of 125?
5.
5. So it becomes 1 over 5 squared. The answer is 1 over 25. 1 and done. Easy. This one's going to be tricky, I think. Now, what is 0.375 as a fraction? The numerator is 15. It's 15 over something. It's not 2. If it's not 15 over 2, because that'll be 7.5. It's 15 over 4. Okay.
Mm-hmm.
Now, how did I know that? Here's a dumb way of doing this. You have this decimal. You want to express this as a fraction. What you need to do is you need to kill the decimal. What that means is you need to shift this decimal point 3 units right. Like that. The only way you can do that is if you multiply it by 1,000. You're always going to be multiplying it by 10 power something. So either 100,000, 10,000. So you get 375. Okay, what we did was we took this number, we multiplied it by 1,000, but we're also going to divide it by 1,000 because you can't just multiply a number. because you're simply multiplying by a 1, because 1000 over 1000 is a 1. Then you get 375 over 8000, like that. And you can plug this into your calculator. There's a button that looks like this that reduces any fraction to its bare bones. This thing reduces to 4 over 15, I believe. Maybe I'm wrong there. 375 divided by 8000. It was 3 over 8, not 4 over 15. 3 over 8. What did I say? I said 15 over 4. That is 3.75. Oh, I meant to say 15 over 40. Yeah, I missed a decimal point. 15 over 40 is 0.375. But anyways, this is how you can bare bones anything. Like for example, 0.625 is 625 over 1000. If you press 625 and this button over 1000, press equals to, that'll give you the bare bones, which is 5 over 8, like that. That's how you can reduce a fraction. So we know this thing is negative 256 to the power of 3 over 8. Now that negative sign, does that apply to the 3 or the 8?
No.
No, it does not. That's outside. So what did you do here? You do negative the 8th root of 256 to the power of 3. What's the 8th root of 256?
It's 2.
2. So you have negative 2 power 3. What's the final answer?
It's 8.
Yeah, negative 8. And that's going to be the final answer for this question. What about C? What can we do here? What would be the first step?
Could you cube root it first?
Yeah, here it's a little bit tricky because if you cube root it, and then if you take the power of 4, you're gonna get a positive number. But we know that negative sign, yeah?
Mm.
That negative sign does not apply to the power 4. Notice how it's outside the power? This negative sign does not apply to the power 4. So if you do cube root it, you need to understand that the final answer, well, I mean, you can cube root this, okay? You need to understand that the final answer must be negative. So you multiply by negative 1. Otherwise, if you take a 4th root, then the answer is going to be positive. But the answer here is not positive because the negative sign does not go with the 4. So here actually what's best, I think, would be if you have a calculator, you just do this bit first. So negative 0.027 to the power of 4, which is some number. It's a big number. By big, I mean a lot of digits like that. And then you cube root that, so you don't make a mistake. That's the answer, negative 0.0081. It should be negative. The answer there should be negative. Do you understand why the answer here is negative and not positive, even though there's a 4th root? Sorry, a 4th power? It's because this,
Because it doesn't apply to the negative.
no, it does not apply to this negative sign here. That means no matter what the answer is, the final answer must be negative. But if you do cube root first, 4th exponent later, then you're going to get a positive answer. So keep that in mind. Sometimes they try to trick you. E doesn't have that problem though. E you can do both ways. You can take the 4th root of this first, 0016, and you can cube it. They'll both give you the same answer. So 0.0016 to the power of 1 divided by 4 to the power of 3. The answer is 1 over 125, or 0.008. So for E, it doesn't matter which one you do first because there's no negative sign. This is, okay, before we do the next one. What's 1.6 as a fraction? We just need to shift this decimal point 1 to the side. What do we multiply this by to shift this decimal point? That's always the goal, is to get rid of the decimals. Do we multiply? It's always going to be a power of 10. You multiply it by an order of 10. Is it going to be times 10 or times 100 to get rid of that decimal?
100.
No, it's going to be 10, right? 100 would be 160, so it also works, but you want to use the lowest possible. So I'm going to multiply this by a 10 because that's a 16, but you can't just multiply it by a 10. You have to divide it by 10 as well because this just means you're multiplying by a 1 because 10 over 10 is a 1. So 1.6 becomes 16 over 10, right? And that reduces to 8 divided by 5. There we go. That's how you get a fraction out of it, out of a decimal. You just shift the thingy.
Okay.
So this becomes negative 7776 to the power of 8 over 5. You take the fifth root of this, so negative 7776 to the power of 1 over 5, which is negative 6. And then you do to the power of 8. The answer here is going to be positive because with this is in a bracket. That means this power 8 also applies to the negative sign. Anytime you have an even exponent, the final answer will be positive. What about this? Power of 4 cubed means you multiply 4 itself 3 times. What's the meaning of 4 power 2.5? So this is a communication problem. Any ideas? Is it multiplying itself 2.5 times? Would that be the answer? No, that would not be the answer. You got to think this in terms of a rational exponent. 2.5, what's that as a fraction? What is 2.5 as a fraction? Remember, I taught you how to do this. What do we multiply this by? 10 or 100?
10.
10, so it becomes 25 over 10, right? What's this reduced? 5 over 2, yeah?
Mm-hmm.
So 4 to the power 2.5 means 4 to the power of 5 over 2. So what does that mean? That means you're square rooting 4 and then you're taking to the power of 5. And that's the answer to this question. 4 to the power of 2.5 means you square root 4 and then you multiply itself 5 times, okay? So the answer will be
Mm-hmm.
2 power 5, it'll be 32. If you say this is like 4 being multiplied itself 2.5 times, you'll get a big 0 on the question because that's not right. What does that even mean, being multiplied itself 2.5 times? So you multiply itself twice and then you multiply itself like half a time, like that. That's not the answer. You gotta always think of, when it comes to radicals, Always think of in terms of rational exponents. Rational exponents just means a fraction on the top. 0.875. What is this as a fraction? First, we multiply it by some number. Is it going to be 10, 100, or 1,000 to get rid of this decimal?
1,000.
1,000. So it's going to be 875 over 1,000. Next, you're going to press 875, a power B button, 1,000 equals to, and that will give you the fraction, which is 7 over 8. There we go. So what does it mean? 4 to the power 0.875? It just means it's the 8th root of 4, okay? And then you got to take it to the power 7. That's all it means. First, take the 8th root of 4, and then multiply itself 7 times. All right, let's call it a day there for today.
Okay, thank you.
See ya.